you can see the board. It's been connected to the motor, and it's being supplied by 12 volt, and currently at idle it's consuming 20 milliamp. So on the screen, not sure if you can see this, but basically I've got idle current being printed, and it's being printed I think every 1 second roughly, less than 1 second actually. Anyways, that you can see there's a bit of an offset in the current readings, it's jumping around. This is, I would say it's due to Xmega's not so perfect ADC input. They have hopefully fixed it in the later devices, but they had some issues with the earlier Xmegas, and that's what this design is based on. Anyways, alright, well let's run through some of the commands, and I'll start the motor to clockwise direction, and it spins. You can't see it spin, I might hook up a propeller motor later on, but you can see the current consumption went up, and the noise. I like to hold the motor so it doesn't glide off. I'll increase the rounds per minute to, you can probably see it on screen as well. So you can see on screen the RPM has gone up to about 150-164,000. Now this is of course the electrical RPM, and the current consumption there is being reported 2.6 amps, which is, you can see that 400 milliamp offset still exists. So few extra features I've put in. I'll turn it down a bit. A few extra features I've put in this little controller board. Basically, scenarios you can expect to have in a flight situation, in an RC, helicopter or plane, where the battery starts dying, or there's a fault somewhere in the board, so the current goes up. So for example, if I reduce the voltage down to a level, I think it was about 9.1 or 9.2 I set it to. So if I keep reducing it, what will happen is that let me just ramp up the motor first a bit. So if I keep reducing the voltage, you will see the motor will actually automatically ramp down and stop. Okay, so it's gone below 9.1, and the motor ramps down rather than doing a very fast stall, and the status LED tells you, actually, let's just move that here, the status LED keeps flashing, telling you that there is a problem. Now, the flashing won't go away until I send a new command out, and the source of the problem has gone away. Until that goes away, the light will keep flashing. Now the light flashes with a slow blink, which tells you it's a voltage problem. I have made it a faster blink for a current problem. I can't create a current problem now because in the code I've put in a current problem fault at 10 amp. With this power supply I can only go up to 5 amp. I have however tested the code by recompiling the code with a lower current fault limit, and it did work. So I've put in all those features, current and voltage protection. I might as well put a blade on the motor and give you a quick demo. I've actually got another motor that has the blade mounted on it, so I'll swap this motor and give you a quick rundown. So I have swapped the motor to a different one, one with a blade installed on it. I'm just going to use the battery to hold the motor, otherwise it's very difficult. So I'll try and rotate this clockwise so it doesn't fly off, but rather pushes up. So here we go. It's going up, and hopefully you can see the readings on the screen. So at the moment, electrical RPM is about reading 8,000, 9,000 RPM. If I up this, see the current consumption is going up. It ramps down and you can see the status LED is flashing. So that's about it, guys. If you have any questions, just leave them as comments down the bottom. I'll try and get back to you when I can. Thank you for watching this. Have a good day.